Today we are starting with the processor logic design. So in this video it will be concentrating on some designs of the components that is inside the processor. So what is a processor unit? So it is a part of the digital system, and it helps in implementing the different operations in the system. What are the different operations? It includes the arithmetic logic, shift, and the transfer operations. Okay, so the processor unit, when combined with the control unit, it performs some, or it will be monitoring the sequence of different micro operations, and that will be called as the central processor or central processor unit. Okay, CPU. So the processor together with the control unit will be forming the um, central processing unit. So in order to monitor all these operations, it makes use of many components, which includes bus and the data path that is used by the bus, and the bus will be having some lines inside, like address lines, data lines. So they will be shared by the different components inside the processor. So it will then, in order to perform the different operations, it will be making use of some control gates also. So control gates, it will be formulating, control gates formulate the given path are multiplexers, decoders, അപ്പം ഓരോന്നിൻ്റെയും ഫംഗ്ഷൻ അനുസരിച്ച് what the multiplexers does, what the decoders does. But as we have seen, multiplexers, it will be helping to choose the source. അപ്പം source will be chosen and the data will be placed on the bus. അതേപോലെ decoders എന്ന് പറയുമ്പോൾ it will be choosing the target. So from the bus, how the information is loaded to the target. Those things we have seen in the previous classes. Okay. So now what we are going to see here is how the bus is being organized. That is, we said that we are having a, inside the processor, you will be having, one second. Inside the processor, you will be having the arithmetic logic unit, and which performs the different operations. So arithmetic logic unit, it will be having two inputs. Okay, inputs, one will be from the A bus and the other will be coming by the B bus. Performs the operation. A shifter is there which helps in performing the shift operations. Okay, so some arithmetic operations can be done only with the help of, it needs the help of the shifter also. Some arithmetic operations requires the help of the shifter also. Okay, so like multiplication and division. So shifter is also there. If shift operation is not required, means this just gives or loads the result and place it on the bus to be loaded to the target register. Okay. So here we are having some registers R0 to R3, and it is being connected to the multiplexer. What is the purpose of multiplexer? It will be helping to select from the different registers, source registers. Source in a select ചെയ്യാനായിട്ട്. Okay, it will help in selecting the source from the different registers. So A select is like in order to select the first operand. B select means in order to select the second operand. From the registers, it will be taken as input, and the connections will be given like this. Okay, connections, either R3 can be given as the first operand or it can be given as the second operand. So the connection will be given like this, and then if first operand will be going via the A bus, second operand will be going to the arithmetic logic unit via the B bus, and then it will be given as input to the ALU, performs the any arithmetic operation that is being required, and then what it does, the result will be loaded to the shifter. If any shift operation requires, means that also will be done in this shifter, and the result will be placed on the S bus. Okay, so the S bus will be having the result. So So this is the S bus. S bus will be having the result, and decoder, what it does, when it is being enabled, um, the destination will be selected. So some select signal will be there in order to select the destination. So here, once the decoder is enabled and the destination signal is selected, a load is being initiated to the register. If R1 is being selected, means this load signal will be initiated, allowing the R1 register to fetch the data from the bus. Okay, so R1 will be enabled to load the data from that is the information that is stored currently in the bus. So this is the organization of the bus with the 4 processor registers. So this is the explanation related to that program, diagram. So the register connected is connected to the 2 multiplexers to form the input buses A and B. Selection lines of these multiplexers select one register for the particular bus. Okay, selection lines. The selection line A select and B select over here. Okay, it selects one register for the multiplexer. And A bus and B bus are applied to the common ALU. The function selected in ALU determines the particular operation that is to be performed. Shift micro operations are implemented in the shifter, and the result of micro operation, it goes from the output bus S into the input of all the registers. Okay, and then the destination register that receives the information from the output bus will be selected by whom? The decoder. Okay, decoder will be selecting the destination register. So decoder, when it is being enabled, it activates one of the register load input to provide the transfer path between the data and that is on the S bus and the input of the selected destination register. So the output bus S, it provides the terminals for transferring the data to an external destination. So output bus S, it will be storing the current final output, and it will be loaded to the target register. Also, you will be in case here one input data is given over here. So this input data can be selected from outside, apart from this, other than from this registers. Okay, so either it can take from both the both the operands can be from the registers, or one of the multiplexer, it can take the input from outside, and that is denoted by this input data. So one input of multiplexer A or B can receive the data from the outside. Then the control unit that supervises the processor bus system directs the information flow through the ALU by selecting the various components in the unit. Okay, so these entire things, it will be controlled by who? The control unit. It controls all the processes that is being performed by the different components of the processor. So for example, if you are considering this operation, R1 is replaced by R2 plus R3, addition of 2 registers R2 and R3. So what is the first function performed? First, it will be selecting the operands R2 and R3. So multiplexer A selector. So this multiplexer, it will be selecting, using this A select, it will be selecting the registers R1. Okay, sorry, R2. The first one will be selected by the first multiplexer will be selecting the register R2. Second multiplexer will be selecting the register R3, and where it will be placing, first multiplexer will be placing it on bus A. Okay, bus A, and second multiplexer, it will be placing it on bus B. Diagram le nokkumbo ariyan pattum. First multiplexer, what it does, it places the output on bus A. Second multiplexer, it places the output on what is being read from the register? It is being placed on bus B, which will be given as an input to the ALU. Okay, so what the ALU does, it will be performing the arithmetic operation A plus B. So arithmetic operation given in the example is addition. So that is why A plus B. And then what it does, shift selector. Shift selector, either it will be using it for direct transfer or it will be given as an output to the bus. The value that is obtained from ALU will be given as an output to the bus without performing any shift operation. Then comes the decoder in order to select the destination register, which helps in transferring the content of bus S to the register R1. So this is the operation that is being performed for this micro operation based on this diagram. Okay. So here in this diagram, one more thing is there. Similar to the input data that can be received by one of the multiplexer, the shifter can give the output to any other source also. Other than the registers, it can give to memory or something. It can be loaded to the memory or to any other data registers. Similar to the input data that is being received, it can give the output also to some other registers or to some other output. Okay, for direct or input to receive in the folder, direct you can give the result for output also. Another one concept is there. Here we are having registers to store the data. Else we will be retrieving the information from the memory. So inside the processor, a small area is dedicated to store the data, and that area will be called as the scratchpad memory. So the register in a processor unit can be enclosed in a small memory unit. So without accessing from the memory, the contents can be loaded in this small memory unit, which is small when compared to that of the main memory, and it is within the processor, and that is called as the scratchpad memory. So it is included inside the processor unit. Cheaper alternative to collect processor registers through a bus system. It's a cheap, instead of using the registers, we can make use of the scratchpad memory also. So the difference between the two systems is the way in which the information is selected for transfer in the ALU. So what is the difference? How the information is being retrieved from the scratchpad memory and the normal general purpose registers, it is varied. So in a bus system, the information transfer is selected by the multiplexer. In case of bus system, multiplexer, making use of multiplexer, the information is being retrieved from the register, where here in this case a register must be selected specifying its address to the memory unit. So here scratchpad memory is it needs to retrieve a memory. The processor needs to know the memory address to retrieve the content from the scratchpad memory. So a register that will be used to select the address of the scratchpad memory. So this you will be able to understand with the help of the diagram. So here scratchpad memory is there, which will be having some set of registers. Imagine to be as some set of cells. Okay. So if it is having some set of cells, means each will be having some address. So the address where the data is being stored, it need to be obtained from the multiplexer. Okay. Earlier what happened, from the registers using the multiplexer, it choose the A operand as well as the B operand. Here from the scratchpad memory, directly it is taking the value from the scratchpad memory. Instead of making use of multiplexers over here, instead of making use of two multiplexers between any source and the